Okay. Here's our plan. We're getting close to Thanksgiving break. At this point, we have spent a lot of time solving quadratics by factoring, solving by quadratic formula. We did a mixed practice day. Here's what is required. I have checked almost everybody's 5.1 and 5.2 from this practice page. This is required to be done. So most of y'all are halfway there. You just have 2 more sections. That's due. I'm checking before the test day, but technically it is due on test day. The 5.3 packet that is linked here, the mixed practice packet with all those 18 problems, I'm not taking that up. That was that yellow packet. I have that in case you were not here. I'm not taking this up. This is strictly just supplemental. It's basically topic 1, solving by factoring, quadratic formula, and then the last page is a little bit of writing. It is so long though, like you don't have to turn it in. I did put an answer key up with all the work. So if you are like struggling with this, like you can at least go and look at the work. And again, some of them factor, some of them quadratic formula. I've caught a couple mistakes. I'm trying to kind of fix them as I catch them. But you can see all of that there. And then I also put the 5.1 to 5.2 answers only. A lot of you guys have checked these. But remember, when I'm doing homework checks, I'm just looking to make sure you have like appropriate work. As far as checking the answers, that's up to you. So I have those there, and I think I've caught all the mistakes by this point. So we have 2 more lessons in this unit. Today is about solving a system of equations between a linear and a quadratic. Honestly, I think like it's not terrible. Y'all have done a lot of solving at this point, and so these really are not that bad. And then Thursday will be our big calculator day where we do all of our applications, quadratic regressions. It's pretty much everything is done in the calculator. So you get kind of a break from all the solving, but it's calculator stuff you're going to have to know. And then next week we will take a check for understanding over this week's stuff, test review, and then test is Wednesday, Thursday next week. If you're going to be out, it is advised that you communicate with me so that we can try to take the tests either before break if possible, or if not, arrange something afterwards. Does everyone understand the flow of the next 2 weeks? We do? We're good? Okay, to page 10 in the notes. So this is now like the second half of this unit. It's going to be its own test grade. It's a lot shorter, this second topic, like question-wise, it's a lot less than the first one. But what this is about is a system of equations, which we did. That was our very first unit, was solving systems. We just did linear equations. What we're going to do today is a linear equation with a quadratic. So we're talking about a line and a parabola. Graphically, we'll do a little bit of graphs, and I'll show you how to work the calculator a little bit, and then the next couple of problems are going to be algebraic. I believe your test is going to ask you to do it algebraically, but I do want to show you how to do it graphically as well. So when you find the solution to any system, which again, you have studied systems before, it's the point or points where the 2 graphs intersect. So we're not finding the x-intercepts anymore. That's just when you have just like one equation that is a parabola. These types of problems are going to be where a parabola and a line are intersecting. Okay, solving wise, it's a little bit different. The kind of end result is going to be an actual ordered pair that is not necessarily on the x-axis. So there are 3 different cases. Again, the first case would be that your parabola and your line intersect at 2 places. I'm going to do this one first, 2 solutions, because I feel like this is the most common one. So like you have a quadratic graph, which we know that's called a parabola, okay? Looks something like that. I don't know, just sketch that in. And then your linear function could intersect that quadratic graph at 2 places. So you would have 2 solutions there. And again, these would be like ordered pairs, x and y. X and y, you'd have 2 ordered pairs. That's an example of 2 solutions. This is your most common one. You also can have a quadratic graph and a line that intersect at just 1 place. So like my line just basically touches the graph 1 time. It's like tangent to it at 1 solution. I don't know if we'll see one of those in the notes. We'll see when we get there. Yes?
Would the line be able to go like kind of straight up? Would that also?
Like a vertical line?
Yeah.
Yeah, it could. It could. It wouldn't be a function if that were the case because it is a vertical line, but you could have like a straight vertical line or even a straight horizontal line too. But they could cross twice, they could cross once, or they could cross never. So you could have a quadratic graph and your lines just like chilling below or maybe above, I don't know, something like that. They just never cross. So graphically, that's kind of what we're doing. I am going to show you how to do these graphically in your calculator. If it is possible that you can use the skill that I'm doing for 1 and 2 to check your solutions, but on your test, it's going to say solve it algebraically. So you're going to have to be able to show the algebra, but you may use the calculator to check. And especially as we get to like our next lesson, knowing how to find intersection points in the calculator is going to be big. And we just take away the calculator so much that sometimes just not sure if everyone knows how to use it. So we'll just jump through these real quick and then we will get into the algebra here. So to solve with a calculator, you need to get both of your equations in y equals. So get both equations in y equals. So for number 1, my quadratic equation is good. So I'm going to go to y equals. And if y'all don't know what I'm doing, please ask. We don't use the calculator a whole lot, so I'd rather you not be confused. Like, ask me and I can restate what I was saying. So we have negative, again, negative, not minus, negative, x is up here by alpha, and then this button right here, kind of diagonal from the 7, will get you an x squared. I think it's faster than doing like the caret thing. So x squared plus 4x minus 3. So there's my quadratic. Again, both of your equations need to be in y equals. If you're going to use the calculator, how do I change this bottom equation to be in y equals? Just move the x. So y equals 1 minus x. And then go in y2, 1 minus x. Okay? So quadratic in 1. And this is, you can only really do these in the calculator if you have, like, if you can isolate y. I'm going to show you some examples where your squared equation is the variable y, so you can't calculate this one. Okay, so we have our parabola, we have our line, pick graph, and you're going to see.
Why does it take like a while for it to like load?
I don't know. Okay, who needs help? So this gave you some space, again, just to sketch. If you want to go get an exact sketch, that's fine. You can. More power to you. I'm just going to kind of sketch what this looks like. A parabola is opening down. It has 2 positive roots, something kind of like that. This is not to scale, but I don't really want to take the time to do the points exactly. And then it is going something like that. Okay? The whole point of doing this in the calculator, though, is so that way we can at least save ourselves a little bit of time from the graphing. But what we're going to end up doing, and again, this is something that I'm going to go over next class as well, is being able to find an intersection point right here. So how many solutions are we going to see?
2.
We're going to see 2 solutions because there's 2 places that it crosses. So I can see that there are 2 places, here and here. And then I want to calculate those as an intersection. So first thing is type them both in y equals. Make sure you can see where the graph is, which today we should be able to. We'll talk about changing windows next time. And then after there, we're going to press these buttons. Write this down. Second, and then trace. Okay, so second's the blue one. Trace is right next to graph. If you can see in blue, right above it says calculate. Sometimes I say second trace, sometimes I say second calculate. They're the same button though. Okay, so second trace. And then what we're going to do today, we're going to do some other stuff in second trace next class. But for today, we just want to calculate those intersection points, which how many are there? 2. So that means we're going to repeat this process 2 times. So choose number 5, which is intersect. You can press 5, you can scroll to 5 and press enter. And then I really want you to pay attention to what your calculator is saying at the bottom. Okay, especially like moving forward to our next lesson, you got to be able to understand what the calculator is asking you to do. What does it say right now?
First curve.
First curve. And where we were in the calculator. Does everyone's calculators still say first curve? Okay, now if you have a colored one, so this is what first curve means. I'm taking the time so that way maybe next class won't be super complicated. Chromebook closed. Now. Okay, first curve means you have two curves on the graph. Now, one of them is a straight line, but that's what the calculator calls it. And it's saying, hey, I'm talking about the one in blue, which do you see how at the bottom, if you have my colored calculators, which this is what you'll use on the test, it says x equals 0, y equals -3, or something like that. Does yours say blue? Is it blue numbers there?
Yes.
Letters, numbers, whatever. Okay, so that's saying, okay, are you on the first graph that you want me to find the intersection in between? Since there are two, what I kind of do is like scroll near the first intersection point that I'm finding. So I'm just going to scroll near the leftmost one. It doesn't matter which one you find first, but I'm going to scroll near it. And I'm going to press enter. And when I do that, what does your calculator say now?
It's red.
Second
It's
curve,
red.
and the colors are
Red.
red, which means it's on the red graph. And that's, since we only have two graphs in, this shouldn't be anything that you have to change, but just so you know, you can. Yeah.
How'd you get to second? Mine was first.
You have to press enter.
Okay.
So then press enter again through second curve. Okay, you don't even need to move. Just leave the little cursor where it is, near the left one.
Yes.
Does it matter what your numbers are?
No, it doesn't. I just get near one at a time.
Yes.
Then it's going to say guess, and as your calculator is saying, do you want me to guess the intersection between the two places that you just clicked? And we're going to press enter again.
He's guessing.
And then it will say your intersection, and it will give you an X and a Y. So our intersection point, so second trace 5, and technically what you did is you press enter 3 times. 3 times. And so we will see that one of our solutions, and again, my graph is not at all to scale, but I don't really care, is 1, 0. Now, there are two places that we have solutions. We cross 2 different times. What you will not do is start scrolling aimlessly on your graph right now to find the other one. You are going to start the process over. Second, trace 5 again. Now you may scroll, move the little blinky thing near the other one. Near it, doesn't have to be, it just has to be closer to that one, so your calculator will grab that intersection. Enter, enter, enter again, and you will see the other intersection point is 4, -3. So we can see how bad my graph is. I'm going to keep it covered. Okay?
Bruv.
So, I want you to try number 2. You can type number 2, even though this, what form is this quadratic in?
That's technically
What's your vertex form? You can type in vertex form. You don't need to convert it. You can put that in Y1, Y2, calculate your solutions, ready, set, go. Okay, so again, you can type these exactly as they're written, as long as they're in Y equals. You don't have to change forms or anything, as long as Y by itself. I do like to always look at the graph and get an idea as to like how many solutions am I going to have. And again, your solutions can they don't have to be pretty numbers. We're going to see some that are very not pretty on one of these examples. But if you look closely, I know it's kind of zoomed out. There are 2 solutions here. Did y'all get those?
Yes.
Okay. So again, I'm going to go to second trace 5. I'm just going to scroll near the first one. If you're lost, I can't see the cursor right now, but I can look. My calculator says X is 0, Y is 16. I can't see it because I'm only going from -10 to +10. So I'm just going to kind of use my arrows until I get, oh, there it is. Yay. And I'm going to go near this one. Enter, enter, enter. 2, 0. 2, 0. Anybody get anything weird?
No.
Anybody get anything with an E in it?
Probably.
Okay, great. Second trace 5 over here. Scroll to the other one. Enter, enter, enter. And the other one is 3, -2.
Dilly data. Dilly
Okay.
data.
What is your question? And this is why I'm harping on making you start over every single time. If you find one intersection, you're like, I just want to go back to the other, and you just start moving with your arrows. You can literally move anywhere on the graph. And do you see can y'all see mine? How it's just giving me these ugly decimals in black? That's just giving me the exact location of the cursor, and it's not actually calculating anything. You can't assume oh, this looks super close, I'm going to write that down. If you want to find something, you need to actually be calculating it. Second trace, and doing one of these calculations, okay? All right, that is how you can do it in your calculator to check, which again, if you are able to check these in your calculator, more power to you. We're doing a lot more calculator stuff next time. So if the calculator is not something that you know very well, then you better have your thinking cap on next time. Flip. 11. Solving systems algebraically. Okay? I will be asking you to do it this way on the test. Is everyone clear on what I will be asking you to do it on the test?
No.
Algebraically.
Okay.
Which means you can only use your calculator as a way to check your answers, which I always encourage. But I got to see the algebra. You have to prove to me that you know the algebra. Okay, here's some steps for you. Use substitution to plug in one equation for the other. So we've done substitution with linear equations like the second day of school. We're going to kind of keep that idea here. Use substitution, plug in, and then you'll have an equation that's all in terms of the same variable. Okay, so you'll notice your systems will be a little bit different. You're going to have two equations. You're going to have a y and an x. When we do it algebraically, we're going to get it in terms of one. So like only x's or only y's. Simplified to standard form. This is a lot of typos. Simplified spells wrong. This isn't my fault. And set the equation equal to 0. Okay, so you might have some moving from side to side. You might have some distributing. All those fun things. I'm going to make a note here that's going to be best for you to keep your A value positive. So do whatever you need to do to make sure that your x squared term has a positive coefficient. That is my advice. A lot of these we will solve by factoring, but I do want to put on here that technically, because you'll be getting a quadratic equation, you could quadratic formula. And we're going to have one that we have to. Okay? So, but I think for the most part, most of them will factor to make it a little bit easier for you. Then you're going to set each factor equal to 0, solve for the variable. That's not new. The fifth step is like the most important step and is the most forgotten step. You are finding a solution point. So when you set equal to 0, factor or quadratic formula, you are only finding the x's. On topic 1 of your test, when you just have one quadratic and we say solve the quadratic, you're done when you find the x's. But when you have a system, how many equations will you have when you have a system? 2. All of you should know that confidently. Also, it will say solve the system. Topic 2, solving systems. This is when you have to go back and make sure that you find the other value. Okay? Again, it's the most important, it's the most forgotten. So let me show you what that looks like. All right? We've got a couple examples to do, and then we've got practice. Oh, it's not that bad. Okay, number 3. Y equals 2x minus 15, y equals x squared minus 6x. Both of these are set equal for y, so it truly doesn't matter which one you sub in. But how I do substitution is I find an isolated variable. Again, that's one that's all by itself. It's either y equals blah, 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 or x equals. And then I sub that value in to the other one. Y'all remember this way back when? You did it in Algebra 1. We did it at the beginning of Algebra 2. So here we go. So I now have the equation 2x minus 15 equals x squared minus 6x. So this is what I was talking about. The only variable now in this equation is x. Before I had y's and x's, I couldn't do anything with that. Now I'm all in terms of x. So we okay with that? First substitution. Check. Okay, now we need to make sure it's in standard form, set equal to 0, keeping our a value positive. So I want to keep x squared here, which means I want to move this, and I want to move this. Okay? So we'll have 0 on this side. I'm not moving anything with an x squared, so that's going to stay 1x squared. But I'm taking away a 2x from a negative 6x. And what is that?
Minus 8x.
Minus 8x. And then I'm adding 15.
Good job, Matthew.
Is everyone okay with that without me showing the small steps? We good?
No.
Okay, I would suggest to try and factor first because I do think it is easier. We are going to come across one that doesn't. But I would for sure try factoring here because what kind of factoring is this?
Easy.
Easy.
Why?
Because
Because-
x is the a's 1.
because the a value is 1, and the only time you can use this factoring method is when the a value is 1, which means you just got to number puzzle it, and then those numbers are going to slide into the factor.
Minus didn't.
So our factors will start with x and x. We need two numbers that multiply to be positive 15, add to be negative 8, negative 5, and negative 3. Those number puzzles go directly into the factors. Do not change when you're going from the number puzzle to the factors, okay? No change there. But now you've just factored, and I will say this happened a lot on y'all's CFU, and I don't think I've lectured this class about it yet. Y'all, this is not solved. This is, you factored it. Congratulations. We've been doing that for weeks. How do you actually solve this? Set each of your factors equal to 0. I had a lot of y'all, I kind of flipped through the CFUs, and a lot of y'all missed that, and that's a big time red flag, okay? We cannot do that. So x minus 5 equals 0, x minus 3 equals 0. How many solutions are you going to have? 2, because I've got two different x's. One of them is at, and one of them is at 3. But this is where this type of problem is different than the ones we've been doing. What type of problem are we actually solving? A system. Which means step 5, we have to take our two x's and we got to go over here and we got to find the corresponding y's. Now, this step is not as hard and shouldn't take as long, but you cannot forget to do it. Okay? So let's talk about x being 5 first thing. I usually go back to, it doesn't really matter whether you plug back into the linear system or the quadratic. I think probably 9 times out of 10, going into the linear system is going to be easier. So that says y equals 2 times, I'm using the x value 5, minus 15. 2 times 5 is 10. 10 minus 15 is... So one of my solutions is the ordered pair 5, negative 5. And you write these as points. Okay? Now the other one, I'm going to find y, and I'm going to just use my other x. X equals 3. Do you see what I mean by this step's a little bit easier? Just plug in. 2 times 3 minus 15. 6 minus 15 is... Why are you saying what?
I did something wrong.
Did you plug in a positive 3?
Yeah, but I used the other equation.
That's fine. You should still get the same answer, but it's going to be easier, typically, to plug into the linear equation.
Oh, yeah. I got
Because if you plug it into the quadratic, you just have to square it and all that stuff there, too. Okay?
That's not bad.
So that is the process. Does anyone have any questions before we get to number 4? Because number 4 is kind of a doozy. We okay? Yeah. Oh, wait, hold on. There's a problem that we had to change. I don't think we haven't done it yet. Okay. All right. Let's move to 4. Yes? With me? Everyone? Happy? Yes. Okay. Are we still hot? I'm still hot. Okay.
Something's going to be negative.
We'll fix it. All right. Number 4. Y equals. I do have a y equals equation here, so I'm going to box my trinomial, and I'm going to plug it in. Equal to y. We okay with that? Just the substitution of an expression. We good? Yes. Okay. All right, let's rewrite. X plus. Now, if there was a coefficient on that y that my arrow is pointing at, you would have to distribute that all the way in. So just be mindful of that. There is not. This is just plus y, so it's a direct substitution. I don't have to change any signs. I don't have to multiply any numbers. I'm like all good right there. Is everyone okay? Okay. All right. I've got some like terms that I can combine here. I've got to move this 6 over. And I also want to be in standard form, so I'm going to put my x squared first. And it's positive. What is my x term going to become? And what is my constant going to become? And this whole thing is equal to 0. Now, I think it's easier to try and factor, but what is your number puzzle going to look like here?
Impossible.
Yeah. What does it look like? 1 on the top and
-4.
Is that possible? So if you cannot factor, then what do you have to do?
No solution?
No.
Quadratic.
Quadratic formula. I'll show you a no solution. You have to at least check the quadratic formula. Okay? All right, so what is our A? We are going to find the discriminant. What is our A? What is our B?
Discriminant.
Okay, calm down. What is the, how do you find the discriminant?
You just do the formula.
What is the formula?
Minus 4 squared minus 4 times 1 times 1.
Thank you, Judy. I heard you.
Equals 12.
Okay, so B squared minus 4 times A times C.
12's not pretty squared.
Oops. Make sure you guys put this stuff in parentheses. We haven't done this for a little while. So make, oh my. All right, what did we get?
12. 9.
12. So our discriminant is positive 12. So will we have real solutions?
No.
Yes.
Go, yeah.
And how many will we have? 2. All right.
None.
To the formula. X equals negative B, which will be positive. I write the double negative and then fix it. Plus or minus square root of
12 over 2
2
times 1.
times 1,
Just 2.
which is 2. So I'm going to have a positive 4. I'm going to be over 2 plus or minus. I got to simplify square root of 12.
4, 3, 2, 3.
2 square roots of 3. Very good. If you're struggling with that, we shouldn't be. We should not be.
No. You just can't be struggling.
Well, if you're struggling with it, then you need to be in tutorials, which I had almost no one in here today. So that's on you. Okay? All right, final answer. Oh, okay. Need to discuss this because this happened on the CFU. You guys, listen to me. I want you to look at what I'm saying. You with me? You cannot simplify anything until you simplify that radical. So, yes. I understand there will be a 4 and a 2 here, and those will simplify, but it is illegal to simplify that until you simplify the radical. Remember, how many numbers do I circle? 3. And you are not going to get that third number until you break down that radical. This happened on the CFU also. This happened last year, and I just remembered it Friday afternoon. So, make sure you hear me now. You have to simplify the radical first before you simplify the big crazy fraction. Now, the 3 numbers I circled are all divisible by what? 2. So, x is equal to?
2 plus or minus square root of 3.
Okay, do I have to put over anything?
No.
No. Now, how many solutions is this actually? 2. So I am going to, because this is a system, what do I have to do after? I have to do both of them. X plus square root 3 to minus square root 3. But then what else do I have to do? What I say is the most important and most forgot about step.
Plug that.
To find the y's.
Plug that geometry.
Have to find the y's.
Plug that
So
geometry.
here's my arrow. Find the y's. All right, this is going to get a little bit weird. Okay, let's do the 2 plus square root 3. So the first one will be 2 plus square root 3 plus y equals 6. Again, I'm going into the, make it easy on yourself, go into the linear equation. You're trying to find y. Okay? What do I have to do?
Move some stuff.
Move some stuff. What do I have to move?
2.
2, which I can take that away from the 6. What else do I have to take away?
Square.
Root 3, which I'm just going to put that at the end because I don't have a like term for that. So this will be y equals 6 minus 2 is 4 minus square root 3. So that is a solution point. 2 plus square root 3,
No.
4 minus square root 3. It's a number. It's a point. It ain't pretty. But it is that is one of your solutions.
That's despicable.
Okay, I'm running out of room for the other one. I'll figure it out. So we'll do this one. 2 minus square root 3 plus y equals 6. Again, subtract the 2. Add the root 3. 4 plus square root 3. So your other solution is
2 minus root 3, 4 plus root 3.
Dude, good job, Matthew.
root 3. That is the most fun problem we're going to do today, I'll tell you.
Most fun or most like work?
Most work.
Oh,
I say fun.
That wasn't even terrible.
Well,
I know, Matthew.
Doesn't get
I wasn't
sarcasm
expecting y'all to
yet.
think that was fun.
knows that. There's a joke.
I've been doing this for 10 years. I know what y'all are going to hate.
You're just being too British, Matthew.
Okay? All right, let's go to the back page. All right, okay. This was the one that had a mistake on it. Number 5. This is supposed to be a positive 2x. Everyone, alert, alert.
Positive.
Change that one. It's supposed to be a positive. You guys try 5 and 6. And then I want us to come together and try 6 and 7. Okay? 5 and 6 on your own. We'll check them in a minute. Okay, so this is the number 6. This top one is the number 6 that you should be doing. After you finish, I've got 5 up here in case you got stuck. Again, there was a typo on 5. My bad. Okay, I want to do the bottom 2 together. So if you're behind on this one, catch up. And we'll be done after those 2. Okay, so here's the work for this one. Notice, I always suggest that you make sure that you are factoring when your A value is positive. So I got here, I did leave a negative A for a second, but then what did I do between here and here? I divided everything by -1. And I can do that because what's 0 divided by -1? Still 0. So all my signs change. Easy factoring is only when the A value is positive 1. So if you have a negative A value, either move everything over to the other side or do what I did and divide out by a negative. It's going to make life a whole lot easier. A whole lot easier. Now, up until this point, you wouldn't do this because your teacher told you to do it algebraically, but you could check all of these equations by putting them in y equals. 5 is already set up to put them in y equals. 6, just manipulate. Manipulate this bottom equation like we did in the first graphing one. So you could check all of these answers. Number 6 is not checkable. Why?
Because as a y squared.
As a y squared. So you're going to be getting x equals equations, and you don't have an x equals button on your calculator. So with this, I do want to do this one. It's mathematically, algebraically going to be the same process, but you will be factoring with the y squared, which means you're finding the y values of the solutions first. So you're finding the second numbers of the solutions first, and then you got to go back and find the x's. So it's not really like anything wildly different. However, it just is worth noting it is going to be slightly different. So I'm going to plug in this guy for x. But I'm going to be extra careful because what's in front of that x? A negative. So I'm going to use parentheses this time because I have to make sure the whole expression that I'm subbing in for x is negated. So I have to, you could do it in one step. I like to write it out and then do it in 2 steps, but you, as long as you flip everything, so this will be y minus y squared
Do we have to do
plus 7y. I don't think so.
because if y squared plus 6y.
I think it will factor. I think. I don't know. We'll see when we get there. Now I'm going to move stuff. I'm going to combine. I'm going to move. And I'm going to rearrange. So my squared term first. Oh, here we go again. I got a negative y squared. I don't want that. What do I do? Multiply it by -1, divided by -1. Either way. It's going to make it y squared minus 8y plus 15 equals 0. This is still easy factoring.
Oh, yes.
Because you got to move that 2 over.
Yeah, I think I just did it.
I've just done it.
Okay? 2 numbers that multiply to be positive 15 add to be negative 8.
-5,
That's negative
Didn't we
3
already
and
do
5.
that?
Yeah, we did actually.
We did. Okay, but be careful here. Your factors are going to be y minus 5, y minus 3. So then you're finding, how many solutions will you have? You will have 2. But when you go and you write those ordered pairs, you just found the second numbers. I sometimes, when I do y's, very first thing, y'all see what I did? How I went ahead and wrote my answer blanks and I just put my y values in there, like in the correct spot. I went ahead and did that so that way I just don't mess that up. And then I got to go find the x values. Okay? So I have find x, and this will be,
You just do 1 minus 2 for
what?
Like-
Well, you're plugging in for y, so it'll be 5 minus, oh, yes. Yes. You can rearrange the equation. That might be easier, to rearrange the equation to solve it for x to begin with, but either or. Either or.
crap.
You
Okay.
wish to move the 0 to the other side.
Yeah, like this 0 over
Yeah.
here? Yeah.
If it was a good number to do
That's so awesome. Because he thinks it's funny.
Yeah, you can always swap left and right of the equation, but yeah. What's the other one? 5, oh no, so what am I doing? 3,
You got it.
okay,
Recess, baby.
all right, so last one. Ooh, last one.
Or do we have to do it?
We, okay, it's not that bad. All right, first thing that we haven't come across. Are we all okay? Can y'all see that? Our 2 solutions there. So every single problem so far, I've had one of my variables already isolated. We don't have that here. Again, both of these have x and y on the same side. You want to rearrange the bottom equation? Let's do that. Let's do this one as y equals negative 3x minus 8.
Okay.
I'm recording. Please stop.
Can you technically make a x equals negative y squared minus 2 and then
That could work too. That might be easier.
do it that way?
That might be easier. Well, either way, this is going to be a... Just hang with me. No, just hang with me. Just do it this way and we'll just roll with it because I already started. Okay, so I'm going to plug this in for y up here. Okay?
You have to foil that.
You do have to foil. That's why I did it this way. So this will be negative 3x minus 8 times negative 3x minus 8. I went ahead and already wrote it twice. Are you all okay with that? Yeah? You are going to need to multiply that out. Set it equal to 0. Here is the work. I did a little bit differently last year, but basically what happens is that you get a negative discriminant, which I calculated. It is not factorable. You could quadratic formula, but we are going to call, with these types of problem systems, we're going to call it, will someone get the door? No real solutions. Okay? All right. Work on your homework now. We'll grade the CFUs later.